Good afternoon. It is afternoon. Yes, good afternoon, everybody. I'm Richard Kershaw. I'm Technical Manager for Cemex UK. I'm responsible for concrete, mortar, screed, aggregates, dry silo mortar, and our technical systems team. I'm also part of the UK delegation at TC104, so that's the main technical committee for concrete in Europe, and the mirror committee B517 for BSI, and a few points in between: geotechnical works, lower carbon concretes, concrete test methods. I'm also the chair of BRMCA technical panel, and my colleague Mark is trying to get me involved in BritPave. So, as he does. So, with over 1,400 concrete plants, Cemex are the world's largest producer of ready-mix concrete, with volumes of around 50 million cubic metres, although being on an ERMCO board meeting in Turkey 2 weeks ago, they produce 150 million cubic metres of concrete per annum. So it puts the UK volume into perspective. I think we all agree that decarbonising the construction industry is everyone's top priority. It's not just about cement production, it is everything that we do. I'm quite active in tunnelling, and there's lots of focus on electric vehicles being used in tunnelling to reduce the associated CO2. And as Stephen touched on, we're aware that our production processes, when we're talking about cement, has a huge carbon footprint. Simon touched on the differentials between blend materials, where we're looking at geopolymers, where we're looking at alkali activated materials, when compared to traditional Portland cements, CEM1. GCCA looks at the cement industry at 5 to 8% of global emissions. In the UK, we're somewhere around about 2% of total. So lower than global, but still a high value. Within Cemex, we have a Future in Action programme, and what we're looking to do there is achieve sustainable excellence, okay? So increased circularity, natural resource management. We're fully aware that we make cement, but equally we're fully aware that we dig holes in the ground to bring out aggregate. We've got a primary objective of being a net zero company, and our programme focuses on 6 pillars, okay? So we're all about more sustainable products and solutions, so it's not just lower carbon. Going back to 2020, we launched our Virtua range of lower carbon concretes, and that was our main focus. But since then, our CEO sitting in Monterey has recognised that we've got lots of other products that can actually lead to more sustainable construction. Could be lower carbon, or could be just sustainable. Decarbonisation of our operations. That's really solely focused on cement and cement manufacture, okay? And we're using 2 main levers there. One will be alternative fuels, so rather than using fossil fuels, gas or coal, we're powering our kilns with biomass, and that's across Europe that we power our kilns with biomass. Effectively waste material that doesn't go, to stop it go into landfill, and a huge focus on clinker factor. So that is reducing the percentage of pure cement clinker that is going into our products. And our regional president has set us a target of 50% clinker factor by 2030, which is rapidly approaching. So in the UK, because we make concrete slightly differently, because we have mixer blends, we're around about 84%. But if I look at my colleagues in Poland and Germany, who pre-blend their products, so produce a CEM rather than a C in concrete, they're around about 63, 64%. So they're very close to our target of 50% clinker factor. Circular economy, really focusing on the use of recycled materials. And I think looking at some of the faces in the room, we'd all be familiar with the push to use recycled aggregates, crushed concrete aggregates back into concrete. It is not new, but it's got an increased focus because of circular economy. Currently, Cemex in the UK, about 10% of our concrete plants use recycled aggregates or crushed concrete aggregates back into concrete. Water and biodiversity, air quality comes into that as well, and we've got a big focus at the moment on measuring fresh and non-fresh water. Previously, it was recycled versus mains, but the World Health Organization has a definition of fresh and non-fresh. So weirdly, you can have a recycled water, which is still fresh. Personally, I wouldn't drink it, but nevertheless, it's still classified as fresh. So there is 1,000 milligrams per litre of solids, and if you're over that, it's classified as non-fresh. If you're under that, it's classified as fresh. So we're actually measuring that and presenting that as a UK business. Innovation and partnerships. It's about what we're doing today, of course. It's about what Simon previously presented in terms of Semblend. It's what Jack presented earlier in terms of Optipave. You know, it's where we as Cemex, where we as a concrete industry, wearing my BRMCA hat, can fit into these innovative products. And of course, promoting a green economy. And I think you'll see that everywhere you look now from a cement and concrete and aggregate point of view. It is focused on lower carbon. It is focused on more sustainable. I think it's safe to say in a room full of BrickPave members that, you know, concrete is a wonderful material. You know, it's the most important manufactured material, both in terms of the amount produced, so that often used, you know, it is the most manufactured material used, the most used material other than water, and the huge impact it has, the positive impact it has on regional economic development. Yeah, if we think about HS2 and the benefits that is bringing to the local area. It provides clean water, Thames Tideway. You know, I was involved in Lee Tunnel, what seems like a long time ago, 10, 11 years ago, and that was the start of Thames Tideway. So bringing clean water requires concrete. Low carbon energy, Hinkley Point. I'm only minorly involved in that with some spray concrete through our dry silo business. But again, a consumer of a huge amount of concrete to bring cleaner energy. You know, I live in Nottingham. I live about 3 miles from Ratcliffe-on-Soar power station, and that was turned off this week. So that's the last coal-fired power station in the UK. So low carbon energy, nuclear energy, hugely important. Durable homes, schools, roads, railways, etc. Concrete's fantastic. It uses locally sourced materials. Most of our production plants are very close to the job site, so very low CO2 when it comes to travel. Loads of performance benefits, cooling, heating. You know, you don't need air conditioning necessarily if you've got a concrete building. It's fire resistant. It does not emit smoke. It doesn't rust. It doesn't rot. And it's 100% recyclable, and it uses an awful lot of recycled materials as well. So I've already touched on recycled aggregates, crushed concrete aggregates, fly ash, GGBS, thus keeping these materials out of landfill. Loads of people talk about lower carbon, ultra low, low. The difficulty with it is there's no actual definition for what a concrete can be classified as, okay? Now, there's lots of work going on at European level to define what a reference concrete is, and it's likely to be CEM1 in the UK, but if you go into Europe, it's likely to be a CEM2AL, a Portland limestone cement that's being used as a reference material. And then within EN206, whichever version it's likely to be, there'll be what's called global warming potential reductions. So you'll have your reference concrete, let's pick a C3240 in CEM1, which will have 280 kgs of CO2. And what the specifier is then able to do is say, I want a global warming potential reduction of 10%. So it will go from 10 to 90. So you can specify a 90% reduction to your reference concrete. Now, that brings some challenges because lots of people in this room may never ever use CEM1 concrete. So is it really fair to use a CEM1, the worst polluting, as your reference? But you've got to start somewhere. So I think on a contractual level, if previously you used 40% GGBS, maybe we can use that as the reference point and look to optimize from there with further additions, whether that's fly ash, whether that's further GGBS, or of course the use of CEM2AL. But at the moment, that working group is looking at a reference cement in each European country, and it's likely to be CEM1 for the UK. As a concrete technologist, we love a standard. Okay, everything we do is driven by standards, and I really loved Donna's presentation when she was really getting into the definition of complaints. It was making me very nervous when she was talking about compressive failures, but I'm pleased to see that that was within the road structure, not within the cube. So if we look where EN206 FITS, so the European standard for ready-mix concrete, that's the hierarchy. So we have our national building legislation, then we have Euro codes, then we have execution, we have precast concrete, then we have EN 206. Okay, and then within EN 206 we have all these reference materials for our raw materials, for our admixtures, for how we test it, for how we assess it, just in case it does go wrong. But everything that we do is driven by standards. And in November 2023, we reissued an amended version of BS 8500. So BS 8500 Part 1 is for the specifier, and BS 8500 Part 2 is for us as a supplier, okay? So these were reissued in November 2023, and they were much awaited for a number of reasons. One was the guidance on digital monitoring of concrete quality, and I think that's a positive step forward. We've certainly seen major infrastructure products at HS2 utilising the digital measurement of concrete quality. Therefore, you don't have to sample the concrete, or you don't have to sample the concrete at a frequency that was within the specification. Reduces manual handling, reduces waste. You know, a significant amount of waste of concrete is because somebody takes a bucket to measure the temperature of it. A significant amount of concrete is wasted because somebody takes a bucket to do a slump test. You've then got to get rid of that material. You've then got to wash out your material. So guidance on digital measurement was included in 8500 Part 1. Good for me, it redefined the production day for air content testing. So if we're talking about pavement concrete, we used to have to test 1 every 50 cubic meters of concrete. We can now test 1 every 400 in line with compressive strength for conformity. Sulfate attack, chloride ingress and carbonation. Again, some changes in BS 8500 Part 1. And in both Part 1 and Part 2, and this is the exciting bit, this is where the test comes in about cement designations. We could then include BSEN 197 Part 5 cements. So in blunt terms, that's CEM2AL, Portland limestone cements, plus fly ash, plus GGBS, CEM1 plus limestone fines, plus GGBS, plus fly ash. So going back to basics, and we think about the opportunity for lower carbon cements. Let's say pre-November 2023, not strictly true, but we'll use that as an example. We take a Portland cement. And we then used to add GGBS, typically from 10, 15%, all the way up to 95% if we think about some of our geotechnical works. And that is a binary cement. What the changes to BS 8500 in 2023 allowed us to do was to add this limestone, and it's limestone fines to BS 7979, okay? To become a ternary cement. So again, it's probably terminology that you've all heard. So again, going back to pre-November 2023, most concrete plants out of major conurbations only have 2 silos. Okay, so it was, again, interesting to hear, you know, some of the challenges, as Simon highlighted, with bringing in niche, novel, new cements. You go to, I think it was Cambridgeshire or Norfolk, pre-disposal to Breedon, Cemex plants would have had 2 silos if you're lucky. Okay, 1 stock in CEM1, 1 stock in GGBS, or 1 stock in CEM1, and 1 stock in CEM2 BV plus SR, which is pre-blended with fly ash. So these were the cements that pre-2023, November 2023, you'd have typically seen coming from a concrete plant. CEM1, 0% GGBS, all the way up through to 95%, which is a C3C. At all points in between, C2A-S, C2B-S, C3A plus SR, C3B plus SR. Okay, so that's what you would have seen. What we can now do is stock CEM2AL. So CEM2AL is pre-blended clinker plus limestone fines. We produce it at Rugby, we pre-blend it at Tilbury from a Cemex perspective, and it's typically got about 15% limestone fines in it. So you're immediately lowering your CO2 per tonne from CEM1 to CEM2AL. Pre-November 2023, we could only blend GGBS at less than 36%. So those that are familiar with design chemical classes, that means you couldn't produce a plus SR concrete, okay? So you could only produce it for a few exposure classes. So moving forward, what we are doing as Cemex and what others are doing in the industry is stocking CEM2AL at our concrete plants, a lower clinker cement already, and then combining it with GGBS, thus giving these new cement designations, okay? The most common one will be C2C-SL, okay, and plus SR when it's greater than 36%. So previously we had CEM1, C2S all the way to C2Cs. We've now got these, okay, C2A-SL, again, all the way through to C3Cs. So when people talk about CEM2s, I always say, which CEM2 are you talking about? Because you've got a lot of CEM2s there. You've already got a CEM2AL. If you read BS 8500, I think we're up to 63 CEM2s. So it's always worth just checking which CEM2 or C2 are you actually talking about. And then there is a third option, which is taking a silo of limestone fines. Okay, so a 7979 limestone, sticking with CEM1 if you choose to. Because again, lots of work going on in the industry about reducing carbon in CEM1. Still having a silo of GGBS, and you may notice I've focused on GGBS rather than fly ash. The option with fly ash still exists, but you know most people are talking about CEM2ALs plus GGBS because let's be honest, it gives you a lower carbon concrete. So if you've got a silo of CEM1, if you've got a silo of GGBS, if you've got a silo of limestone fines, if you're lucky enough to have 3 silos on a concrete plant, you can produce all of those cements. Okay? So you've got a wider range of cement designations available. You've got a wider range of exposure classes that you can supply into. Okay? So lots of different options when it comes to CEM1, GGBS, and limestone fines. That's Cemex. Our preference is CEM2AL and GGBS, but other options are available, and I know lots of other companies supplying into infrastructure projects are focusing on this because it gives you better flexibility, perhaps. Yeah, you can start using your limestone fines for rheology reasons, to control your bleed, yeah, to improve surface finish, and you can add up to 20% limestone fines and call it part of the cementitious, but you can put in another 3, 4, 5, 10% to improve the rheology of your concrete. But there's an awful lot of work that, oh, there's a slide missing. Okay, there's an awful lot of work that went into this. There's a slide missing, apologies. So the MPA, Mineral Products Association, MPA Cement, commissioned a study at the BRE into 25 different cement combinations. Okay, that was a 2-year study. We looked at carbonation, we looked at sulfate resistance, of course compressive strength, chloride migration, free solver resistance, very important obviously into this room, and also alkali silica reactions. So there's an awful lot of work that went into it before ternary blends were included in BS 8500. What we've done as Cemex, and if I'm honest, I'm pretty sure what my colleagues in other concrete companies have also done as well, is to implement our own test program. So we've carried out our own laboratory and plant trials. We have to produce what's called a main relations analysis, which is free water cement ratio to strength. Okay, so we have to have that curve available before we can put these cements on the market. We have to apply corrections for admixtures. Does a PC admixture give the same water reduction in a CEM2AL or a C2C-SL plus SR as it does to a CEM1 and a C3A plus SR? We need to look at the aggregate fraction. Is our percentage fines going to be the same because I've got a more cohesive cement? So actually I can take some sand out, possibly. I need to look at consistence. Does it need the same amount of water to give me an S1 or an S4 slump? What about additions? You know, do I use the same percentage of GGBS to give me the same compressive strength performance? Because again, one of the focus areas as technologists is wastage, excess of design. Yeah, you want a C2835 concrete. I design that probably to be a 42. I really don't want it to be a 43. So we're focusing very much on excess of design. So these corrections come into play. And then oversanding. You know, we typically work on 4 and 8% oversanding, but can I be 3 and 7? If I'm 3 at 7, I need less water than 4 and 8, therefore I need less cement. So again, it all builds to reductions in CO2. CEM2AL isn't a new cement, okay? When I was growing up, we used it in the southwest back in the late 80s, yes, and it was called Portland limestone cement then. So it's not a new cement, but the opportunities to use it have grown with BS8 500. We have 2,350 odd tests year to date, 2024, in using CEM2AL, and we've got close on 600 tests using CEM2AL with GGBS. So again, lots of data available on a wide range of concretes, including paving concretes, which I can share with you, and probably around 70% of our concrete plants are currently using CEM2AL. But it doesn't stop there, because I've got to implement it. So I've got to program plant computers to make sure that we can supply it. I've got to change the contract documentation when we've moved from CEM1 to CEM2AL. I have to implement a factory production control system. I have to implement a continuous conformity system in line with EN 206. Any cement manufacturers in the room, they need to look at their blend level certification. Okay, so we need that in accordance with BS8 500. And then we've got specifications. So appreciate this is geotechnical, but if we look at BRE IP 1705, that only talks about CEM1 and GGBS. Doesn't talk about CEM2AL and GGBS. So we need to discuss that on a contract by contract basis. The airfield spec 033, only talks about CEM1, doesn't talk about CEM2AL. One of my favourite hobbies is correcting people when they talk about PQ concrete being a PAV2, and I always say, no. The airfield spec 033, that's true PQ concrete, because I'm measured on compressive strength of cores at 7 days, so it makes me nervous. But that hasn't caught up yet. But hearing Joe and you this morning, obviously specification for highway works. Am I allowed to say catching up? Is catching up to the new standard with lower carbon cements. And what was really pleasing, I think it was in Joe's presentation, where where the Highways England, Highways Agency are allowing performance-based concretes, which gives the opportunity for Simon's business when it comes to innovative, novel cements, when it comes to what Michael was presenting around graphene. We can start discussing those because Highways Agency is allowing performance-based materials. And then training. An awful lot of training for our salespeople, for our planners, because they've got to get their heads around C2C-SLs plus SR. And dare I say, it's relatively easy for me because I wrote the standard. So future in action, that's what we did, that's what we're doing today, okay? If you can have a future today. But obviously what we're looking to do is, what does the near future look like? And we've already heard from Michael about graphene. Graphene in concrete isn't new. We've certainly been involved. I think we're involved with you, Michael, on a project through Innovate UK. But graphene enhanced concrete definitely has its place, but where does it sit in the standards? Because exposure classes are driven by cement designations. Graphene isn't included as a binder or an addition or a cement yet. So where does it fit to give the CO2 benefits? Could we further use high performance or ultra high performance concretes? Ultra high performance concretes never have seemed to have caught on in the UK compared to my colleagues in Europe, where they're talking about 150 megapascal concretes. Can we make pavements thinner? The designers in the room will be horrified by what effect that has on bending movements, but nevertheless, can we make pavements thinner if we're using high performance concretes? Fibre reinforced, I think it was Jack who talked about microfibres. If I'm honest, 5 and 8 kgs per cubic metre horrify me in terms of how cohesive that concrete's going to be. Nevertheless, is there an opportunity there? Macrofibres, microfibres, steel fibres, or of course a blend of fibres. What opportunities are there for digitalisation? As already touched on, new BS8 500 allows specifiers to specify the use of the digital measurement. What benefits can we get from that? Electronic tickets was the starting point. Actually not carrying out consistence testing seems to be the most logical step. Lower clinker cements. You know, clinker factor is key in everything that we do, but how far can we take lower clinker cements? Some great work going on looking at 50% limestone fines with GGBS, with SEM1 or SEM2AL, but we're limited there because the standard only says you're allowed up to 20% limestone fines as part of your cement fraction or your binder fraction. So Flex 350 needs to come into play here so we can get further benefit. Finely grained materials. You know, everybody seems to be talking about micronization, yeah, making, you know, whether that's clinker or additions ground finely. Micronization, I always call it just grind it finer, but you know, I've been doing it a long time, so I can't get my head around all these buzzwords. But nevertheless, grinding materials finer gives you better benefit, but potentially has a knock-on impact when it comes to concrete rheology. So you need to think about water, you need to think about admixtures and the effectiveness of admixtures. Cement-free binders, certainly again not new, depends how far you want to go back. The Russians were using them in the 1800s, but certainly clinker-free, alkali-activated cementitious materials are something that have been around for a while, and I'm not sure for what reason, but have never really caught on. We had our own version. We did some work with David Ball Group. I know Capital Concrete have done some work with Wagner's with their earth-friendly cement. Everyone got excited about it about 3, 4, 5 years ago. We haven't seen it caught on. My personal feel is it just needs a bit of energy for us to start looking at it again and talk about the benefits. And then finally, and the big decision really as a cement producer and cement producers is what do we do with carbon capture, storage and reuse? Okay, it seems like lots of people in the industry see that as the most logical step. Certainly we've got to focus on reduce before capture. So what can we do to reduce CO2 before we're then looking to capture it? Maybe I would say that because we've got Cement Works that sits in the middle of Rugby Town Centre. I don't sit in one of the hubs where I can easily take captured CO2. Okay, it's not like I'm up in the northwest, and I know Heidelberg are doing a fantastic piece of work at Padeswood with carbon capture, but they've got the opportunity to take it somewhere. So there's a big focus in the industry on what do we do with carbon capture, storage and reuse. Is it that beneficial when it takes an eye-watering amount of money, power and water to capture your carbon? And then what do you do with it? We're looking at somewhere in Split, our cement factory in Croatia, and we're putting it onto barges, putting the liquid onto barges, and there's some oil wells off the coast of Italy, and we're sinking the carbon in there. So lots of things happening, but there's a big question mark over cost. So hopefully that puts us on time.
Perfect.
Stephen. Yep.
Absolutely perfect, thank you.